The topic is understanding the concept of CI/CD pipelines and GitHub Actions. In this video, you will understand and I will explain you what is the concept of CI/CD pipelines, and I will show you how I implemented GitHub Actions CI/CD pipeline, which includes security, quality assurance, and pushing the final image into the GitHub container registry and Docker. I will explain you all of those concepts and how this pipeline was implemented, what is the architecture and everything. But first, let's understand what is even CI/CD pipeline. By definition, a CI/CD pipeline is an automated software delivery workflow that compiles, tests and deploys code into production. By eliminating manual steps, it transforms software development from a risky, error-prone core into a highly predictable, repeatable assembly line. Simply, you can consider CI/CD pipeline as an analogy which is like the domino. You have heard of the domino effect, where when you push a single domino and it piles up and pushes another domino. It is similar to it, meaning you want to automate the code journey in a way that is triggered by one push. So for example, a code is being pushed in the GitHub. A pipeline, which is analogy of a domino, means that it must trigger something automatically with respect to using pipeline tools and everything. That includes stages, that is testing the application, building the application, scanning for vulnerabilities, code quality, all of those. These are the requirements that an application needs to fulfill, which is previously or the past was done manually. Now to automate those processes, it is incorporated or used as a pipeline. So it is an automated process of triggering all of those as a domino and to get the results and fulfill the code quality and the quality of the application that is being deployed in the production. So CI/CD pipeline has some core pillars. First is continuous integration, CI, continuous delivery, that is CD, and continuous deployment, that is CD. Continuous integration focuses on early code merging. Developers push small code changes frequently to a central branch. Every single push automatically triggers a project build and test suite to catch bugs instantly. So as I mentioned about the domino thing, with respect to continuous integration, we focus on triggering the branch. Specifically, it is not a main branch which is the production branch, which means that we create another branch which is not the production branch, in which we trigger what we aim for. That is, if in the stage of continuous integration, we focus on testing the application, catching the bugs, vulnerabilities, all of those, which comes in the continuous integration. So there's a branch that triggers those responses and catches the bugs and gives us response to fix it in an automated pipeline process, not like you would be performing all of those stages manually. Second is continuous delivery. Continuous delivery automatically places validated code into a non-production or staging environment. Pushing code all the way into production requires a final manual approval click. Continuous delivery means that the code that has been validated or approved in the CI of the continuous integration stage is now into a non-production repository or a staging environment. You can understand continuous delivery as a step before the production thing. As it says, pushing the code all the way into production requires a final note. It is final manual approval click to approve that pre-production validated code or your application. Then continuous deployment, CD. Continuous deployment removes all human intervention. Every code change that successfully passes the entire sequence of tests or vulnerabilities, all of those goes live to real users automatically. So continuous deployment means now all of those pipelines are integrated and working fine, and whenever the new code is pushed, the developers or whatever fixes whatever is required. Then after it is fixed, the pipeline runs and images or whatever is built and the application is automatically deployed in the production thing, which can be either EKS cluster or cloud platforms. So when that process is automated, where the code change is validated, approved, fixed and deployed into the cloud environment without needing to maintain manual process of doing it, is simply the CI/CD pipeline. That was about understanding core pillars of CI/CD pipeline. Now let's understand what are the stages of standard pipeline. First is the source stage, where a developer commits code changes to a version control system like GitHub or GitLab. This event automatically fires a webhook to trigger the pipeline. So stage 1 is where the code is committed, or you can understand it as code is saved into the version control system, which is at the GitHub. When the code is committed, the event of committing the code fires or triggers a webhook, meaning it triggers something inside the GitHub which starts the pipeline, which is like the domino thing I explained you. Then second is the build stage. The pipeline fetches dependencies, compiles the code into binaries and checks for syntax linting. Third is testing stage. Automated scripts run unit test, integration test, UI test. Code analysis tools like SonarCloud can also scan for vulnerabilities or security exposures. So third you can understand as the security or vulnerabilities or whatever testing thing where we are improving the quality of your application. The goal here is to make the application vulnerability free, almost vulnerability free. It can't be 100%, but making sure that application is safe for the end user that is production ready. Fourth is the deploy stage. Successful builds are packaged into container images, that is Docker, and shipped into a staging or production. Advanced strategies like canary deployments may slowly release the update to small percentage of users to verify stability. So as I mentioned, final stage is a deploy stage, where the successful build, that is the test stage, build stage, where we understood and fixed the vulnerabilities, code quality improvement, testing of the application, that is unit test, integration test, UI test, and whatever which we are doing to make the application production grade. After all of these are in place, these builds are packaged into container images that can be Docker images and shipped into the staging or production environment. There exist types of deployments that can be canary, blue-green, rolling updates, A or B testing, shadow deployments, all of those. If it is canary deployments, which means if we release the application slowly to a small percentage of users and verify the stability of the application, and we slowly increase the visibility of the application until it is 100%. That was stages of a standard CI/CD pipeline. Now let's understand and know what are the popular pipeline tools. First is GitHub Actions. It is a native automation platform fully integrated directly into GitHub repositories. Second is GitLab CI/CD. It is a built-in comprehensive tool suite natively bundled inside GitLab. Third is Jenkins. It is a highly customizable, widely adopted open source automation server. Last could be Circle CI. It is a cloud-based platform optimized for high speed and parallel testing. These are the popular tools. There exist other as well. You can search it up. So that was the basic understanding of what is CI/CD pipeline and its concept. Now let's understand how I implemented CI/CD pipeline in my project for my application, as you all know, which is a multi-tier Node.js application, Resumatcher. Resumatcher is a platform I built where a resume is uploaded and it is scanned and understood by the application, and it fetches the results of the jobs with respect to the resume. This application uses PostgreSQL, backend APIs, and front-end is Node.js Express. So my aim was to build a pipeline to incorporate building the image that is almost vulnerable free and it passes the testing of the application, and the final goal is to have that image of my application Resumatcher. So first let's understand this GitHub Actions CI/CD pipeline architecture which you are seeing from all this long. So the strategy is simple. There exists the concept of branching in GitHub. Here by default it is pointed towards the main branch. You can consider a main branch as a production branch. By what I mean by production branch simply you can understand that when the goal of main branch, or you can consider production branch, is to trigger something that must be quality worthy when the result is into the production. Meaning you can't commit something you think is vulnerable and has some code quality issues. When you are debugging something, when you are trying to increase the quality of the code into the production, you can't simply use the main branch, which would mean that you are just using main branch as a testing thing to have your code in the production already, which is not the goal. The goal is to have the production grade application present, not the vulnerable application that has iterations until it is fixed. So to fix that, there exists a concept of branching, where I created another branch to trigger a debugging thing or testing or quality of the code security thing, which means there exists another branch where I would perform and increase the quality of the code, which is the different branch than the main branch. So I named that branch as pre-main branch. You can name it anything. You can also consider this as the pre-production branch. The goal of this branch is to create or build the code, increase the quality of the code, and let it pass the quality of the test. Usual CI/CD pipelines would have something like, if the test or if anything has the vulnerabilities in it, the pipeline breaks or stops until you fix it. But I wanted to have the pre-main branch which doesn't break in accordance with the vulnerabilities in it. I wanted to catch all the vulnerabilities into an email HTML file, so it is something like you know which vulnerabilities are to be fixed and you fix it one by one, and you get the results of those in an email through HTML file until you know and approve that your application is now ready for production, and you can trigger the main branch to publish that fixed code into an image. So it is not like when something in the pipeline or the domino breaks, if suppose first stage of CI/CD, that is OWASP dependency check. If you assume that it has vulnerabilities, if my application has vulnerabilities in it, and the pipeline would break. So that was not my goal. Like, I wanted to have the code and everything testing to be scanned all over, but not push the application which is in the main branch. So pre-main would trigger all of those things, including testing, SonarCloud, Trivy, image, Trivy, file system scan. All of those are triggered, and its results are captured, saved with the help of its log, and it is sent into my email as a result. So it is like I will get all those results, including getting results of the vulnerabilities of my application, and I fix the application understanding its logs, and I perform another commit after fixing into the pre-main branch until I know and until I approve the application as production grade. Then I perform the main branch trigger for Docker publish and to deploy the image into Docker Hub and GitHub container registry. That was the basic understanding of it. You can understand the architecture. It shows pre-main branch, main branch. When the pre-main branch is triggered, it triggers the parent, that is CI security pipeline, and parent 2, that is QA pipeline. So these both are triggered at the same time. What this pipeline does, it has parent 1 pipeline, that is CI security payload.yaml. This is the parent pipeline that uses these child pipelines, that is CI test, CI SonarCloud, CI Trivy, YAML, CI OWASP, CI email. Instead of creating a single YAML with all of these in it, I created separate YAMLs for each stage in the dominoes. You can understand that. So each pipeline has certain stages. So instead of keeping all of those in a single YAML file, I broke down into separate YAMLs with respect to the stages in it. You can think of it as a domino. CI test is a single domino. CI cloud is another domino. So CI test, CI SonarCloud, CI Trivy, which includes image scan, file system scan, CI OWASP, and CI email, which triggers and sends me the HTML report of the scan results. So all of these YAMLs are prepared, and parent pipeline uses all of these pipelines as a path and triggers it. Instead of in a single YAML file, the parent YAML uses the names of these YAML files, and the purpose of CI security payload YAML is simply to trigger this all pipelines. Now same is for QA pipeline, that is QA pipeline YAML file, which is the parent YAML file. Trigger this single dominoes. You can consider like QA Cypress YAML, QA K6 smoke test, QA K6 load testing YAML file, and final, that is QA report, to send me the result of those with respect to HTML into my email. After iterations are performed, I get the information about the vulnerabilities, quality of the code, and whatever, and I fix whatever it is required. Then when I know that the quality is assured and the code is production ready, then comes the main branch trigger, that is Docker publish. This is a single YAML file which has the staging and everything and steps regarding building the image and pushing it into the Docker Hub and GitHub container registry, that is GSCR. If you want to know all of these YAML files, whatever it is in it, I will find the GitHub repository of this project where you can check these YAML files. That is the pipeline thing. Now, if you are not aware of the components or the tools that is used in the pipeline, for example, if you are not aware of SonarCloud, Trivy, OWASP, K6, Cypress, I'll let you know right now. So first is parent YAML file. So it has CI testing YAML file, which includes Jest. Jest is a open source platform or whatever, which has the purpose of testing your application. it performs unit testing, integration testing. So I used Jest to trigger the testing of my application. And there exists a CI OWASP, that is OWASP dependency check, which simply means like your application has certain dependencies and the goal is that your application must not have critical or highly vulnerable dependencies, and it gives me results of the dependencies if there exist certain vulnerabilities that affects the security of the application. So Trivy is also same. It scans the files of your application and gives the reports of the vulnerabilities present. It also has Trivy image scan, which scans the image you are using. You would be aware of the Docker file thing. So it scans the build image of the Docker file and checks if the image you are using is secure or not. It checks the vulnerability of the image and it gives you information about if your image is vulnerable or not, in order to change and use the better or upgraded images. And CI SonarCloud or SonarCube, it is to increase the quality of the code. It scans and gives you results of your code in the application. You can think like CI test, that is Jest, and SonarCloud go hand in hand, because in order to pass the SonarCloud thing, there exists Sonar Quality Gate, which means that it checks for your application code and sees and wants to make sure that your application code is tested with respect to unit testing or integration testing. So when CI test, that is Jest, is performed, it automatically makes sure that the quality gate is improved, meaning the code that is covered is improved, and it scans for the code for the vulnerabilities and whatever in it. So you fix the quality of the code and make it production ready. So that was about security pipeline, that is CI security pipeline. Now let's understand what is QA pipeline. I have used quality assurance Cypress for testing. Simply, QA pipeline is for testing the application. Parent 1 CI security was for security, vulnerabilities and testing. Parent 2 is purely for testing the application, strength, load and whatever. So I used QA, that is Cypress, to perform end-to-end testing. So simply Cypress end-to-end, that is E2E testing, is a software testing methodology where a JavaScript based framework automates and validates an entire web application workflow from start to finish. It executes inside a real browser, just like the human user would, to ensure that all integrated layers, including the front-end UI, databases, backend APIs, and network requests, function cohesively. And another is K6 smoke test. K6 is a open source platform by Grafana. So simply, K6 smoke test is a preliminary performance test run with a minimal load, typically 1 to 5 virtual users for a short duration. K6 smoke test has a purpose to verify that our system or the API is operational and it responds correctly, and that our application test script works before heavy load or stress is performed. And the final is K6 load test. K6 or Grafana K6 is an open source developer friendly load testing tool used to test the performance and reliability of APIs, microservices and web applications. It lets us write test scenarios in JavaScript, simulate thousands of virtual users hitting our system or application at once, and to track how our application handles the traffic. There are some core features of K6. Tests as a code, writes and version control our scripts using JavaScript or TypeScript. It has high performance built-in Go. It uses system resources efficiently to generate heavy loads from a single machine. It handles HTTP 1.1, HTTP 2, WebSockets, gRPC and browser level metrics via extensions, automation ready. It easily plugs into CI/CD pipelines like GitHub Actions to run performance checks on every code update. And again, it is not limited to this test. There exists n number of tests you can incorporate. This is simply 3 tests I performed to ensure the quality of my application, which is Cypress end-to-end testing, K6 smoke test, K6 load test. Also, with respect to K6 smoke test and K6 load testing, the purpose of this test is to check your application real time with respect to HTTPS or triggers of your application running, not just the demo of it. So in order for my application to work, it needs API keys, and for load testing, if I were to perform with the usual or normal scenario of triggering it, it would exhaust all of the API keys or searches available to trigger the application running. So to fix that thing, I used WireMock. WireMock is an open source platform which helps you trigger your application APIs using it. So simply it helps your application being tested without letting your API keys get exhausted. So it serves the purpose of testing your application for load testing or smoke testing without letting your application lose the API keys and its credits. I'll explain you whatever step is involved. It is just the overview of what is involved in this process. And all of these reports are prepared and it is sent via report of HTML, which is triggered by QA report.yaml file. And the parent YAML file is QA pipeline, which uses all of these YAML files to trigger and prepare a pipeline. So now pre-main branch triggers security pipeline and QA pipeline simultaneously and gives me results of those vulnerabilities and or whatever inside a HTML report. So the developer gets that report and it fixes and triggers the pipeline again after fixing until the developer is sure that the quality of the code is production ready, and that developer then performs the main branch or the main trigger to publish the image into the Docker Hub and GitHub container registry. So that was about the overview of the project. Now let's understand it practically how I performed. So first step was to incorporate the email thing I mentioned. I wanted the reports to be sent via email. So in order to do that, I head back into the email of mine, that is Gmail, and I clicked on manage your account. Then I performed search, that is application passwords. I clicked on it. Then I prepared and created application password with the name GitHub Actions. I copied it and I head back into the GitHub repository of my application and I entered action section and secrets, and I created action secret with email user and the secret, that is my email, and then the email password, that is application password I just generated. So now email user is my email and email password is the application password I just explained to you. It is inside the secrets of action secrets inside my repository of my application, that is resume DevOps. And I head back into the bash console. The default kubectl config was for AWS EKS. I changed it to local. This has nothing to do with the project. This is just what I did. So I make sure to mention it in the workflow. Now first thing is to integrate the SonarCloud or SonarQube Cloud. So first I head back into the SonarCloud website and this is the login process. I logged in using my GitHub account and I selected my repository, that is resume DevOps. Then I head back into the access token section and I created a personal access token or personal token of SonarQube Cloud to use that to trigger the pipeline. I copied the personal token and I added it inside the same action secret, that is secret Sonar token. I gave it the name Sonar token and I added that secret, that is the token of the Sonar Cloud. Then I wanted to create the new project. I named the organization with my personal name Muhammad Khan and I selected the repository, that is resume DevOps, and I clicked setup. So now the SonarQube Cloud project is set up inside this beautiful SonarCloud UI. Then I filled out rest of the secret or the variables, environment variable information. First was Sonar host, which is the link of it, that is https sonarcloud.io. Then Sonar organization, which is Muhammad Khan, and this was the final action repository secrets. First is Docker Hub token, Docker Hub username, email password, which I just generated for application passwords, and email user is my email. Google API key is the API key that my application uses. NVD API key is the API key of OWASP dependency check. QA email, CC QA email 2 is same, that is email user, that is the email. Sonar host, which I just mentioned, Sonar organization, Sonar project key, Sonar token. These are all the repository secrets and environment variables that are needed, which I used. Then I head back into the SonarCloud and checked and clicked the analysis method and I clicked on with GitHub Actions, as this is GitHub CI/CD actions, not Jenkins or other. And then I prepared Sonar project properties file. You can go through it. This has Sonar project key, same which we got from the SonarCloud. Sonar organization, same, Muhammad Khan. Sonar host URL, sonarcloud.io. Sources is sonar.sources. Test is sonar.test.inclusion, which means these must be performed, or these are the tests that is included, that is .test.js, .specification.js, and all of these other JS as well. Sonar.coverage, that is sonar.javascript.lcoff.report paths is equals to coverage.lcoff.informo. This is just the syntax of it. Sonar.exclusion, which means that this must not be scanned for testing of the SonarCloud or the code. Now encoding sonar.source encoding which is equals to UTF-8 quality 8, that is sonar.qualitygate.wait equals true. This is the properties file I created in the root folder of my application. Then these are all the configuration setup files in order to perform the testing of the application, quality of the application of this CI/CD pipeline. You can go through it. First is Jest.setup.js, which is related to testing of my application, that is in the parent one security pipeline of unit testing or testing, integration testing. Then there is jest.polyfills.js. Then it is jest.configuration.js. Then it is babel.config.js, which is same for the testing of CI security configuration. Then this is cypress.config.js, which is for QA parent YAML quality assurance. So this is for Cypress end-to-end testing. So it is using base URL that is localhost 3000. The specification pattern for end-to-end testing is files that have .cy in it. For Cypress testing, I wanted to perform test for only a single page of my application, that is home page. To make it simple, I only wanted to scan home page of my application for Cypress. So I back into the root folder and created Cypress folder. Inside that Cypress folder, I created E2E. Inside that, I prepared this YAML file for home.cy.js. So this file is to test the homepage of my application. Then as I mentioned, there exists WireMock for K6 smoke test and K6 load testing. So as I mentioned, WireMock is an open source tool used to simulate HTTP based APIs. It acts as a mock server or server virtualized tool. Developers and testers use it to stub responses, test edge cases, and isolate their application from the real external or third-party services that might be slow, expensive, or not built yet. So it has certain key features, which is HTTP stubbing. It matches incoming request by URL, headers, cookies, or body patterns, faults the simulation, inject network delays, timeouts, bad data to see how our application handles failures. It records and playback, meaning it captures real traffic from live services and replays it later for testing. Request verification. It checks that our application sent the exact request it was supposed to send. Simply, it is used to simulate HTTP based API request. So it acts as a mock server or service virtualization tool. So I created WireMock folder in the root folder of Resume Azure DevOps. Then I created mapping folder inside it. Then I prepared the search.json. Now this search.json has the syntax of what is to be tested. So it has request method is get URL path is /search, response status 200, body results, stub results, headers, content type application /json. This is the standard syntax of WireMock search.json. Then I prepared and created another folder test that includes load testing YAML, load testing JS file, smoke testing JS file. With respect to smoke.js, as I mentioned, it uses HTTP from K6/HTTP. It is triggering the HTTP, that is HTTP 127.0.12, HTTP 127.0.0.1 on the port 3000. And it is same for load testing. It is to test the load of the application by giving it load and to see how it responds to the traffic. It has same port 3000 with 127.0.0.1 mapped to 3000 port. And then package.json that has the package information versions of the applications. It includes scripts as well. So package.json by default has a purpose of storing central configuration and metadata manifest for Node.js package or npm package. It acts as a single source of truth for managing project dependencies, metadata, automation scripts, and build configurations. Also, package.json has scripts section in it. Not like we have created a separate file inside the root folder. Why it has scripts inside package.json? Because the field in a package.json file automates repetitive terminal commands into short, easy to remember aliases. Instead of typing long, complex commands every time we build, test or run our project, we can trigger them using npm run followed by the script name. Key benefits: it simplifies the workflows. We replacing long CLI, that is command line interface arguments, with single word aliases. Standardized development. It ensures every team member runs the exact same commands. Accesses local packages. It automatically looks inside node modules.bin folder, allowing us to run install tools like White, Jest or Prettier without globally installing them on our computer. There is certain common use cases. It is to run the application, that is automating local servers, for example starting by using node server.js, which is with respect to my application. Also for code quality and testing, which is our purpose, to run test suite, that is Jest, for example Jest lint or ESLint. As you can observe, it has script section, it has start, which is node server.js, def, that is white, build is white build, lint is ESLint dot est ext dot js dot jsx dot ts dot tsx, meaning extensions. Test, that is cross environment, node options, experimental VM modules, Jest coverage provider, that is versionate, coverage reporters, that is text, coverage reporters equals lcov, and we can observe that Cypress is also in it, that is Cypress CI, which is Cypress run browser, flag browser, that is Chrome, flag headless, wait is on the HTTP localhost port 3000. I know this is like the hectic configuration thing which I explained, but it depends on your application and how you are preparing. This was with respect to my application, so I just wanted to give you an overview so you have an idea to know that the pipeline looks simple, but it has certain complications or things which go in the background. So you have the information and know that it is simple, but not that simple. It depends on how your application is made and how well you know your application. I would have easily skipped those configuration steps and directly moved into how the pipeline is working, but you wouldn't have an idea how the pipeline is prepared from the root level. So I wanted to give you an overview on how I actually prepared it. Okay, the next steps are simple, which is to prepare the YAML files and run our actions flow or GitHub Actions. So in order to perform that, I head back into the root folder, prepared and created .github folder, and inside that includes the YAML files which you saw earlier in this video, which is CI email, CI OWASP, all of these YAMLs, and all of these YAMLs with respect to CI security is mapped into the parent pipeline, that is CI security pipeline.yaml. Now all testing, that is Cypress K6 load and smoke testing and report for QA, is inside QA pipeline.yaml, which is the parent of it. And Docker publish is a single YAML file for building and pushing images into Docker Hub and GitHub container registry. We'll link the GitHub repository of this project so you can go through this workflow YAML files so you have an idea of how this application works and how this pipeline works. Now, as we have our YAMLs, that is pipeline, GitHub action, YAMLs present and prepared, next is to trigger or perform the commits with respect to the branches. We could have easily performed it using commands, but I wanted to automate it as well. So I prepared two shell scripts. One is premain.sh for premain branch. As you know, premain is for QA pipeline and security pipeline. So this script, when I perform it, it triggers that branch and it triggers CI security and CI QA pipeline. And I have another shell script which I'll explain you after this, which is main.sh, which is for Docker build push for the main branch. With respect to this premain.sh, the script is as follows, which is obviously /shebang, that is hashtag !bin/bash set space -e, which means the script is exited immediately if a critical command fails. You can go through this and understand the script. Mainly it is check the git status first. It echoes and prints the statement that is local changes are detected, and it is auto stashing, meaning it will stash using the command git stash -u -m with the message auto stash generated by script at date. Second is git checkout -b premain, meaning it is to switch into the premain branch. So first it would check that if premain branch even exists. If you're on the main branch, it would check that premain branch is created or not. If it is not created, it would create the premain branch by using git checkout -b premain, and if it is already created, meaning you run this command again or the shell script again, which means that pre-main would be already created. So it would not create that and perform or using git switch and to switch into the pre-main branch. And third is to stash the local changes of your application into the repository and into this branch. Third is git add to stage the current file changes. It is committing by using git commit. I flag allow empty, meaning even if there is no changes in the code and I want to trigger the pipeline again, it would perform the trigger. As I flagged, it's allow empty, meaning even if there is no file changes, Git will always register it as a new commit with the message DevOps CI at the date. Sixth is echo syncing and pushing to remote, meaning it is to sync the remote first, pull rebase and push safely using force with lease. And the last echo is done, pipeline should now trigger. This was the pipeline shell script for pre-main branch I prepared. You can also use it if you want to and if it serves your application. Then next is inside the Git terminal. You can observe that by default we are in the main branch. I gave permissions to this new shell script I prepared, that is premain.sh, by performing chmod plus x, meaning execution permission, space premain.sh, and I performed and ran the shell script by using /premain.sh. You can observe that the shell script has successfully run and triggered the pipeline. You can observe the logs. It checks for the working directory status, switching to the premain branch until done, pipeline should not trigger. Then after the pipeline was successfully triggered in the GitHub Actions, you can observe that email reports of CI security is available. We can observe that Trivy file system, which includes Trivy image scan, Trivy file system is available, .html file of it, SonarCloud report, Trivy image report, OWASP dependency check report as well. I opened the files, that is .html. You can observe that for OWASP dependency check on my first scan, it shows total vulnerabilities, that is 107, that is 107, and there is 30 vulnerable dependencies, so it is quite a lot. Then the Trivy file system report.html, you can observe that there exists quite a lot of dependencies and vulnerability issues in this package with the Trivy file system report. Then for SonarCloud report, you can observe that it also shows the major and the issues it has. And for Trivy image scan report for the DBN 12.13 image, it shows vulnerabilities as well. And inside the SonarCloud, we can observe that the pipeline was successfully triggered and it triggered the SonarCloud, and we can observe it in the UI. After first scan, it showed 107 major vulnerabilities and one critical vulnerability. We can observe that there are security issues and whatever. There is 107 of major, 1 critical, 22 minor, and 1 bug, 52 vulnerabilities, 77 code smells, which is quite a lot. So this was the first initial scan. Really, there is quite a lot of code quality issues, vulnerabilities, code smell, 1 critical, 107 major, and 22 minor. And also it didn't pass the quality gate as well. Then after fixing all of those errors, bugs, and everything, dependency issues, this was the final scan, meaning the scan that shows the least vulnerabilities and least of whatever I wanted. Simply it is like the production grade. After all of those vulnerabilities, this is the final thing I consider as the production grade, or I think should be pushed image for Docker about GitHub container registry. So I performed the shell script again for pre-main. Then you can observe the GitHub Actions page where pipeline is successfully completed. First you can see that the run of unit testing and coverage. Second is SonarCloud. Third is Trivy file system scan and Trivy image scan, and all of those are sent into the email report. And then OWASP dependency check is also sent as an email report. Then we can observe the email that is being sent. CI reports, resume matcher, we can see test summary, sonar summary, file system image scan report, and OWASP dependency check report. And next is QA pipeline. You can observe that it is triggered in pre-main branch, not in main branch. Same for the CI security pipeline. It is in the pre-main branch. As we can see, Cypress E2E is successful. K6 smoke test, K6 load test, QA pass, that is QA report that is to be sent, is also successful. You can observe that email is also sent. with the report.html files. Cypress report, K6 smoke test, K6 load test report, that is .html files, is also sent successfully. Then we can observe the final dependency check of my application. We can observe that there exist 0 vulnerabilities, which simply it is 0. Like you can see, there is no vulnerabilities present. And for image scan, we can observe that there is no vulnerabilities found, 0 vulnerabilities. And image scan, we can observe that there is no vulnerabilities present, which is 0. We can see the test report of our application, Jest test and coverage report, which says pass. And repository, it says my GitHub username Mohammad Khan / resume DevOps, branch is pre-main, commit number, workflow run 30, meaning I had to perform 30 iterations of fixing and everything to reach this reports. Total was around 200 until I reached here. So total test suits 41 out of 41. Test is 101 out of 101. 0 failed tests and suits. Estimation time is 17.591 seconds. And next is Sonar summary, that is SonarCloud security and coverage report, which scans the real-time security issues, severity distribution and uncovered code. Repository is Mohammad Khan resume DevOps, branch is pre-main, commit number. It also has a link to open the SonarCloud dashboard. We can observe the report which shows overall coverage, which passes the quality gate of 80%. It is 87.7%. Uncovered lines is 203, 12 active issues, 67 uncovered conditions. Main thing is like there is 0 high vulnerabilities, 0 medium, 0 blockers, only 12 low, which is simply manageable. You can also observe the coverage by file of the code that is covered and that is not uncovered. We can see that 44 lines are uncovered for upload resume clean.js. Overall coverage is 67. So this is like the comprehensive SonarCloud report inside the HTML file, which is a great achievement in itself. I'm really proud of it. And we can see in the SonarCloud UI or the dashboard, you can observe that it is 87.7 coverage, which accurately matches the HTML report which we just saw. Quality gate is passed, security is B, reliability is A, maintainability is A, hotspots reviewed A, which is like the great. And we can observe the changes from before to now. Before it was a lot of it, like vulnerabilities, code smell, critical, major, minor. Critical was 1, major was 107 as I remember. We can see it is critical 0, major is 0, minor is only 12, which is really manageable, but at all a big deal. So it is great like journey from many vulnerabilities and whatever to reach this point. The quality, that was the CI security thing, that was quality of vulnerability security. Now next is the reports of Cypress. We can observe that Cypress E2E execution for the home page. You can observe that execution is passed, duration is 3 seconds, 4 test is performed, 1 JUnity files, 2 suits. It also has execution console output, meaning the logs is also present in this HTML report. You can see the disclaimer, Cypress metrics are read from the JUnit XML files generated by this exact pipeline run. No test counts or durations are hard-coded, meaning it is not mock, it is actual reports based on the logs of the run performed. Next is K6 smoke test execution or smoke test report. Simply it is passed, that is we can observe execution checks passed, execution passed. Latency is 2.53 milliseconds and it is 100% passed. And we can also observe like the smoke test summary. As I mentioned, it shows the console or the logs as well. You can see in this section K6 console output, the logs are present. And now it is K6 load test execution. It uses 10 views per 30 seconds. That is the load profile. It is also passed. 600 checks passed. So simply means that our Cypress or simply QA and CI security, all of those are passed. With respect to me, I consider this as passed because there is this least number of vulnerabilities and quality is also improved and test is also passed. So which simply means that next step is to push that quality code, paste it as an image and publish or push it into the Docker Hub and GitHub container registry. To perform that, there exists another script that that is main.sh. The command, the script is as follows: /bin/bash, that is shebang, set -e, which is to exit the script immediately if a critical command fails. It's same here as well, like it checks the git status and it performs the stash. And the second is to switch into the main branch. It checks out if there exists the main branch. It obviously exists, then it switches into the main branch. Then third is to merge the pre-main case, like the pre-main now would be the vulnerable, free or least vulnerable production grade code for the pre-main branch, which is to be merged in this main branch for performing this git fetch origin pre-main, git merge pre-main. And fourth is to stash, to bring our stash changes back onto this main branch. Fifth is to stage all the changes, performing git add, git commit. Again, it is so allowed for empty, meaning it would all obviously be performed even if it is empty, to trigger the pipeline. Seventh is to sync the remote first, pull rebase and push safely using force with release. And finally, it is to echo like all steps completed successfully and pipeline is triggered. So that was simply the pipeline of main.sh to build and to trigger simply the main branch and use the final changes in the pre-main branch, which I would consider as least vulnerable or production grade, into the main branch to trigger the Docker pipeline. So next was to perform the script, that is main.sh. We can observe that by default we are in the pre-main branch now. So I gave permissions to the main.sh, that is the shell script, by chmod +x or execution permission, then main.sh. Then I performed the script by /main.sh. It was successful, and now you can see in the last line how it is switched into the main branch. And that shell script ran successfully, meaning it triggered the pipeline successfully. We can observe the GitHub Actions of Docker build. We can see the steps and stages in this Docker build single pipeline. We can see it is to set up the job, check out repository, set up the chemo, set up Docker build X, log into the GitHub container registry, log into the Docker hub, extract the metadata, tags, labels for Docker, build and push Docker image, generate Docker build and push HTML report, Docker upload, build and push report, installed node mailer, email Docker build and push report, build and push summary, post build and push Docker image, post log into the Docker hub, post log into GitHub container registry, post setup Docker build X, post setup chemo, post checkout repository, complete the job. After this, as we can observe in the email, we received Docker build and push report. We can observe that it was success. It says Docker build and push successful. It shows the branch, that is main branch, and platform, that is Linux AMD64, Linux ARM64. I downloaded the HTML report of Docker build and push. We can observe that build and push is successful. It shows the branch, repository name, triggered by the user, digest or the SHA of the image. We can observe that registry publication, first is GitHub container registry, second is Docker hub, and it shows gscr.io kf/resume.devops latest, that is the tag latest, then kf/123/resume.devops latest tag for Docker hub. I think we can observe the multi-architecture build identity, time when it is generated, which is 17th August 2026. We can check the release flow, that is first source, build, gscr, Docker hub. And to finally check if it was successful or not, I head back into my Docker hub account and we can observe that it is last push, that is 1 minute ago, means it was successful. And I head back into the GitHub container registry of DevSecOps and you can observe that it was last published 2 minutes ago, which means it was 100% successful. So that is it for the video today, guys. In this video, you got an understanding of what is CI/CD pipeline. I explained you the GitHub Actions architecture of my project. I explained you how I performed a CI/CD pipeline of my own application, ResumeMatcher DevOps, that is ResumeMatcher application within the ResumeMatcher DevOps repository. And I hope it was insightful and helpful. I tried my best to make it as simple as possible and to make it as relatable as possible with respect to my experience of how I did this project. And if you have any questions, do let me know in the comments. Thanks so much for watching. Have a great day. Bye.